Hello everyone. In this video, we are going to explore a new topic called RAG. It stands for Retrieval Augmented Generation Architecture. It is used to build LLM around your custom data. And what does this whole statement mean? Let's explore step by step. Let's think of a simple scenario. You're in school and you want to, let's create a student first. Hang on. Yes. So let's say you are in school and you want to write an essay. Write an essay on Indian history. And for this, what is the first thing that you would do? You'd go to the internet. Let's create internet in a better way. You'll go to the internet, right? And then on internet, what you will do? You will find the list of websites relevant to your topic. So list of websites, okay. So it will be list website link 1, website link 2, website link 3. Okay, let's increase the size a little. Yes. And let's say website link 4. Okay. Now, from all the websites, not all of them are going to be relevant to your topic, right? Now you are going to select the most relevant website. Let's say most top two relevant websites from which you are going to, and the top two relevant websites you are going to select, and you are going to select those websites to write your own essay, right? So what you are going to do, you are going to retrieve, select top two most relevant websites, link website links, okay. And then using those two links, those two most relevant links, what you are going to do, you are going to write your write the essay in your own language, okay. Now this is a typical representation of the RAG architecture. Easy, right? Now let's understand how this RAG is fitting here. I told you, or we can see this, the full form of RAG is Retrieval Augmented and Generation. So what we are doing here is a user or student is coming, is searching, has a topic that we can call it as a prompt or a topic, has a topic, or initially a user must have some thoughts around that topic, right? Now that user is going to go to the internet and get the relevant links, or get the relevant links of the websites. So it is retrieving from an external source called internet the most relevant links, the most relevant information. So after retrieving the most relevant information, it is doing what it is doing. Let me introduce. Uh, let me introduce. Hang on. Let me introduce uh, another phase. Let me introduce here augment with original idea, augment original thought with relevant website links information. So whatever original thought the user must have had, the user is going to merge it with the information it is going to get from the retrieved most relevant website links. And then the user is going to write the essay in its own language. So this phase is called generation. So the user is generating the essay in its own language. So this is, now the whole term fits here, right? But it does not make sense, or we cannot think how it is going to fit in the technical way, or how we create when a chatbot, how this architecture is going to fit there. So um, let's understand a normal scenario. When we go to a chatbot like chat gpt or 53, or any other LLM, what happens? A user comes, user has a user prompt or a query or a question, types in, and then sends it to the uh, LLM. It can be Chat GPT or Microsoft Copilot or any other LLM or any other giant LLM. Okay, it is going to send that prompt to that LLM. Now this LLM is going to create what? This LLM is going to create what? Is LLM is going to create a generate the response and send back to the user. So this use send back to the user. So this is the normal scenario when we interact with the LLM. Now the think of the again same thing. What if we have to train it on our own custom data, right? So if we have to train it on our own custom data, the ideal scenario again would be to go build LLM from scratch. For that you need to have deep knowledge of machine learning, artificial intelligence. But do we actually need that? And also with the updated information, with the updated knowledge, we will constantly have to update our LLM, and that is going to be very costly, right? So with RAG coming, it is not actually required. So how we are going to uh, use this RAG to eliminate all the problems I have just talked about? Let's again see if we have to simulate the same user generation flow with RAG. How would we do it? Now let's say user comes, user has a query. So again, user is going to come, user enters the prompt into the bot. Okay, now this bot will go to the external source. Okay, this external source and retrieve the, so what I can do, I can say here is retrieve the most relevant information. Okay, from what, from where? It retrieve the most relevant information from our custom data source. Okay, we can have anything, and we are going to talk about a scenario also, a real life application. Now this once user enters a prompt, it will go and retrieve the most relevant information, let's say, and then once it gives that information, we will append, let's say, augment that information uh, with original prompt. Okay, and then we are going to pass it to our LLM. For what? LLM is going to use the original prompt as well as the relevant information from our custom data source and generate what? Generate the response, and then it is going to send this back to the bot, the send it back to the bot. Now this is looking very easy again, but let's go a little deeper. How is this retrieval thing happening? So this retrieval thing is happening like, uh, let's say, okay, so let's say this retrieval or this custom data, it can be very large data or huge. Okay, now for that, what ideally what happens is this huge data is divided into smaller chunks. Let's say is divided into small, split the data into small chunks, and then This data is divided into small chunks, and thus this data is converted into a vector representation, and that is called as vector embedding. Did not understand? Let's decode it. Now that small representation of a small chunk, let's say this chunk can be hi, uh, I am Akansha. Now I am Akansha is female. Akansha is female. Now this chunk, uh, LLM will not understand, or our data or our system will not understand this chunk, right? Now to make our system understand this, we are going to convert it into a numeric representation. That numeric representation is called as a vector, and this vector is going to be a three dimensional or multi sorry not three multi-dimensional array. So, and this whole process is called as embedding, converting it, a chunk into a vector. It is called as embedding. So we are going to create vector embedding, and then we are going to store it in the vector databases for later uses. Okay, just stick to it, and then I'm going to explain how this works. And then, so now when a user will provide the prompt. It will go to our retrieval system. The retrieval system, before that, let's talk about one more thing. Whatever user will give as prompt will also be converted into a vector representation. So we are going to embed that also into vector form. So now this will go to our retrieval system. Retrieval system will go to our vector database. Now retrieval system will go to our, let's see, retrieval system will go to our vector database, not here. Retrieval system will go to our vector database to find out which chunks, how many chunks are relevant to the prompt that user has provided. And how, let's see here an image representation of vector embedding, and let's see how does it look like. So it looks like this, our multi-dimensional representation of vector. So you see there are dots here. So if I select this dot, and if I need to find the relevant info, or the most, or the nearest chunks around this, so these will be the nearest chunks around it, right? So for example, if I am creating um, here, so if I have a dot here, and if I want to create the nearest chunk around it, so this will be the nearest chunk around it, this will be the nearest chunk around it, this will not be the nearest chunk around it, right? So if I have a vector here, if I have a position here, the nearest chunk will be this and this. Similarly, I have a vector representation like this. I will do what? I will convert the user prompt into a vector form, and then find the nearest chunks around it. And then once I find the nearest chunks around it, I'll return the top k element, whatever top k would mean here. Let's say top 10 relevant chunks here. We will return those top 10 relevant chunks here, augment with the original prompt. Like for example, Akansha is a female, and the original prompt would be who is Akansha, and then the new prompt will be who is Akansha, and the most relevant information is Akansha is a female. It will, both will be clubbed together, merged together, and we will send that to LLM, and then LLM is going to use it to generate more accurate response, because it will have information relevant to your system, right? Now we have understood it, a little complex, but we have understood it. But what if we can have a real life example, it will help us understand it better, right? Consider a scenario. You are a user, and you uses You have a website, you uses a website, uh, let's say, that has a support system, right? That has a support system. So you go and then you find the FAQs, or what you can, you raise is the complaint, and then you talk to the representative and then get the solution. And it is all documented in in pages form or somewhere in the database, right? So what happens is, somewhere in the database, uh, somewhere in the solutions database. So here it is, what if we are going to create a dot around this? We are going to leverage the generation capability of a already built LLM like ChatGPT. So what we can do here is, we will get the relevant information from this database. First, for that we have to convert it into the vector embedding and then store it in the vector form. And then for that, the user will go to your website now. Instead of going to the FAQs and again raise the complaint, user will go to your website and ask, I'm facing this problem, do you have any solution? The bot will go to your database and then get you the response, okay, we have seen something similar, why don't you try this approach based on the already proposed solution. This way you will save up, your company will save a huge amount of money on solving the similar problems. So this can be one real life example of RAG. Hope it has made some sense. In the next video we are going to understand, or we are going to create a RAG application all from scratch. I promise, and trust me, we are not going to include this vector thing or embedding thing anywhere in creating that RAG application from scratch. It is going to be very basic, a beginner friendly application. All you would need is a little bit of Python knowledge and you're ready to start building a RAG application. So stay tuned and thank you very much.